Good morning, students. To continue with the 2017 EE paper, the next question or problem is on transients in RL circuits, DC transients during switch off from the power supply. The switch in figure is opened at t equals 0. The current through the inductor at any time t is dash. There are four alternatives, four choices. 2.5 e power minus 40, 5 e power minus 40, 2.5 e power minus 0.25 t, and D option 5 e power minus 0.25 t. Now first of all, students should remember the transient expression for current in the during switch off from the power supply. Switch off from the power supply means once the energized inductor loses charge and thereby it is disconnected from the supply. So here when the switch is in closed position for a long time, this will be carrying some current. Now all of a sudden the switch is open. That means we have to assume that steady state conditions have been reached before opening the switch. Before opening the switch. Now when the switch is in closed position, you have to assume steady state. First you find out what is current through the inductor. So then inductor start losing that current when it is disconnected from 50 volt supply. Now for that, student must remember this expression. I e power minus R by L t. R total resistance in the circuit, L inductance in the circuit, I means maximum current. Maximum current e power minus R by L t. This is IT expression. Now you have to find out this I. That means what is the current in the inductor before the opening of the switch. Now for that I will remind you, an inductor current reaching steady state, after it reaches steady state, an inductor behaves as a current source. This you have studied in initial conditions chapter. So it behaves as a current source in parallel with a closed switch. So this is the point to be remembered. Now I will find I. Now this is short circuit, is it not? So 32 ohms is shorted. Therefore 32 ohms is removed. Next, this short circuit is also across 32. So this 32 is also disconnected. Now what is left over? 6 ohms, 8 ohms, then 50 volts. Now you find out what is current. What is current through the inductor? The current through the inductor is 50 divided by 6 plus 8 in parallel with 8, that is 4. Therefore 5 amperes. Now this 5 amperes divides into 2. 2.5 here, 2.5 here. Therefore the current carried by the inductor is 2.5 amperes. The current. Now the switch is open. When the switch is open, now this 50 volts is disconnected from the rest of the circuit. Now inductor starts losing the charge and no longer you will find this short circuit. Now I will reconnect 32 ohms here and 32 ohms here. So 32, now you find equivalent resistance in the circuit. 32 in parallel with 32 reduces to 16. 16 in parallel with 16. That means 8 ohms. So equivalent resistance in the circuit is 8 ohms. Equivalent resistance in the circuit is 8 ohms. We get 8 ohms. Now you find the current expression. The IT expression is 2.5 e power minus R by L. R by L. L means inductor. And here I will replace this inductor as a current source replaced by an inductor which is losing charge, and it was previously carrying 2.5 amperes at 0 minus condition. Now e power minus R by L t, R by L t, that is 2.5 e power minus 4t. So this is the answer, 2.5 e power minus 4t. So this is how you have to work out transient problem. Thank you.